Well, I guess Mia could watch it too. Okay, let's look at number 1. For number 1, I'm adding these together. So one of the biggest things when you're adding these together is that you need to make sure that you get your decimals lined up correctly. So as an example on this one, you've got 4.159. The other number you have is 16.2. You need to make sure you get your decimal lined up. So it's 16.2. You can add zeros to this if you need them to make that even up. And then you're going to add this together. 9 and 0 is 9. 5 and 0 is 5. 1 and 2 is 3. Bring down your decimal. 6 plus 4 is 10. Carrying my 1, and then 1 and 1 is 2. So I get 20.359. Okay, on the second one there, I'm subtracting. And again, one of the biggest things with these is getting that decimal lined up. So I have 47.32 minus 12.165. I'm going to add a 0 to the top there. Did I have something in my thousands place? What shall we do? Look like good all the day. Okay, so now we're going to subtract. So can't subtract here, so I'm going to borrow from the 2. I make that a 1. And I'm going to make this a 10. 10 minus 5 is 5. Can't do 1 minus 6. I'm going to borrow from the 3. I'll make that a 2. That changes that to 11. 11 minus 6, 5. 2 minus 1, 1. Bring down your decimal. 7 minus 2 is 5. 4 minus 1 is 3. So I get 35.155. Anybody have a question on subtracting decimals? Next, we're going to multiply decimals. So I have 40.3 times 0.21. Does it matter if I line up my decimals when I'm multiplying? No, it does not matter. So I'm going to do 3 times 1 is 3. 1 times 0 is 0. 1 times 4 is 4. Write down your 0. 2 times 3 is 6. 2 times 0 is 0. 2 times 4 is 8. Then I'm going to add this together. 3 plus 0 is 3. 0 plus 6 is 6. 4 plus 0 is 4. And then I have 8. Going to count 1, 2, 3 decimal places. So my answer should also have 3 total decimal places. So I'm going to go back 1, 2, 3. So my decimal will go between my 8 and my 4. On my next one, I have 5.84548 divided by 0.2. So the 0.2 goes on my outside, and this is going to go on my inside. 584.548. Yes? No, he's in. Yeah. So I have to first get rid of my decimal on the outside. So I'm going to move it one place, which means I'm going to move this also one place. And then I'm going to move up. 2 goes into 5 2 times. 2 times 2 is 4. Subtract, I get 1. Bring down my 8, so I get 18. 2 goes into 18 9 times. 9 times 2 is 18. Subtract, I get 0. Bring down my 4. 2 goes into 4 how many times? 2. Subtract, I get 0. Bring down my 5. 2 goes into 5 how many times? 2. 2 times 2 is 4. Subtract, I get 1. Bring down my 4. I don't have a lot of space. I'm giving out space. 2 goes into 14 how many times? 7. 7 times 2 is 14. Subtract, I get 0. Bring down my 8. 2 goes into 8 how many times? 4. Subtract, you get 0. On the next ones, we're trying to decide, is it a natural, a whole, integer, rational, irrational? And it could be multiple of these. So the natural numbers are also called your counting numbers. Whole numbers are 0 and your counting. What? Your integers are your positive and your negative whole numbers. Rationals can be expressed, I can't really write all this out. Rationals can be expressed as a fraction. So they're a non-repeating decimal, what we said. No, I'm sorry, the irrationals are the non-repeating decimals. And then the irrational are the non-repeating decimals. They're like decimals that go on and on and on and on forever, and they never repeat each other. So let's look first at 8. So in 8, is 8 a natural number? Yes. So remember our rule was, if it's a natural, it's everything that's below it, except for irrational. So it would be a natural number, it would be whole, it would be integer, it would be rational. Okay, now let's go to the negative 1.4. So let's start with, is it natural? Is it whole? Is it an integer? Positive or negative whole number? So if I take off the negative, is 1.4 a whole number? No. So if it's not a whole number, okay, then it's not going to be an integer. Okay, is it rational? Yes. So if it's rational, that's all that it's going to be. Just rational. Okay, and then my other one is negative 2. Let's go through my list. Is negative 2 a natural number? No. Is it a whole number? No. Whole numbers are 0 in my counting, and I don't count negative 2. So, is it an integer? Yes. And if it's an integer, it's also going to be what? Rational. If it's an integer, it will also be rational. Okay. On the next side, we have, is it greater than, is it less than, or is it equal? Okay, so we got 2 things we're going to test over. Our knowledge of negatives here, and then absolute values are here. So let's talk about this first one here. I have negative 8.2 and negative 4. Now, when we first look at this, some of us think 8.2 is bigger, right? Because we think about whole numbers. But remember, negatives are, as the number gets bigger, then it actually gets smaller, okay? Because I'm getting further and further and further and further away from 0. So you have to almost think of negatives as like, I owe these people. Which is worse, owing someone $8 or owing them $4? Owing them $8. That's my smaller number. So the negative 8.2 is going to be your smaller number, okay? On the next one, I have the absolute value of negative 13. Well, absolute values measure your distance from 0. So what is the absolute value of negative 13? 13. So I have 13 and 12. Okay, which one is bigger? 13. So 13 is greater than 12. The next one, I'm reducing my fraction. So I have 27 over 81. What will go into 27? Okay, 9 will go into 27. How many times will 9 go into 27? 3. So I'm dividing by 9, and I'm going to get 3 there. Okay. I guess I should have asked what will also go into 81, and that was 9. Kind of said that backwards. So what will go into 27 and 81? 9. 9 goes into 27 3 times. 9 goes into 81 how many times? 9. Now let's look at this. I've got 3 and I've got 9. Will that reduce any more? Yes. What will go into 3 and 9? 3. 3 goes into 3 1 time. 3 goes into 9 3 times. So we're looking for something that will go into both of the numbers, and then we're going to divide. So here I divided by 9. Here I divided by 3. Now, if you'd recognize that 27 goes into 81, which I don't think most people are going to recognize that, you could have divided it in one step. But otherwise, you just take your time and you go through. If you had said 3 goes into 27 and 81, you would have just had a couple of steps to go through when you were doing that. Okay, on the next one, I have number 11. I have 2/3 over 20 equals blank over 21. Probably should have had my variable there, but I'll just put it there, x. Okay, so we're looking for this number right here. So you're going to say, what do I multiply 3 by that will give me 21? 7. So times 7. So the top, I'm going to do times 7. So 2 times 7 is going to give me 14. Now, on the bottom, I have 5 over x equals 25 over 15. Okay, so what would I multiply 5 by to get 25? 5. So I have to ask myself, what can I multiply 5 by that'll give me 15? 3. Now, you can also divide there. You can do 15 divided by 5. That'll tell you that answer there, but 3 would be your answer there. Okay, number 13 is not like super clear, but this is 7/10 divided by 7/8. When we are dividing fractions, we're going to copy, change to multiplication, and then we're going to flip our fraction. So 8 over 7. Copy, change your sign, flip your fraction. Now, what will cancel? The 7s will cancel. And then I've got 8 and 10. What will go into 8 and 10? 2. 2 goes into 8 4 times. 2 goes into 10 5 times. So left on the top, I have 4. And on the bottom, I have 5. In number 14, I have 7 1/3 minus 3 8/9. So in order to subtract these fractions, what must I have first? Common denominator. What is my common denominator? 9. So 9 and 9. So that's going to stay 8. 3 goes into 9 how many times? I said that back. Yeah, that was right. 3 goes into 9 3 times. So I'm going to multiply this by 3. 1 times 3 is 3. So I have 3/9 minus 8/9. What's wrong with that? Can't do that. So you're going to borrow from the 7 You make that a 6. And what do I add to this fraction? 9 over 9. Okay, this is 1 whole, so I'm going to add 9 ninths. So I've got 12 ninths minus 8 ninths. Which is going to give me 4. I've got 4 ninths here. And then 6 minus 3 is 3. So 3 and 4 ninths. And